So I'll proceed in order of what I hear first. So if you want me to do something. Good. What lesson? Chain rule. Good. What question? So can you open chain rule lesson, please? KJ, just give them a minute to open it up. Do you have it on your phone? Or did you write the question down? Did you write the question down? Yeah. Wait, just give people a minute to open it up. Chain rule, which number? Oh yeah, but what number, so I can tell them to look at it? In number 1? Okay, let's write it down. So, what's the function? You can read it out.
1 over.
Yeah? Yeah?
1 over.
This one. Yeah. There are so many ways to do this, and you will get the same answer, but it might look different. But there are so many ways to do this. If you wanted to do this as a chain rule, you could. If you wanted to do this as a quotient rule, you could. And if you wanted to do this as no special rule, you could. Let's look at all 3. So, which do you want me to do first? Chain rule, quotient rule, or no rule?
Chain.
No rule first, I heard. So, what I'll do is I'll change this into 1 over root x minus a half, which will be x minus a half, which is x a quarter. And so the derivative is a quarter x minus 3/4. This is using no rule. Okay, what one do you want to try is next? Chain rule. Okay, so chain rule. You can change this into y equals x minus a half. Now, to use the chain rule, differentiate the outside and then differentiate the inside. So what is the outside here? The minus a half power. So that would become minus a half minus 3 over 2. And then I must multiply by the inside derivative, which requires another chain rule. It's 2 chain rules. Chain rule in a chain rule. It's like inception. So, for the middle piece here, the derivative is derivative of the outside. And then multiply by the derivative of the inside, which is 1.
Oh, we have 3 layers.
We have 3 layers. Yeah. Do you see that movie Inception? Yeah, it's just like that movie Inception. It's a chain rule in a chain rule. In a chain rule. Okay. And I promise you there was another way to do it, which is the quotient rule. Okay, so to do it the quotient rule way, that's 1 over x. What was it? 1 over root 1 over. Oh, hang on. Was there a big root? Yeah, it was like. Oh, I forget now. 1 over. Yeah. Okay. 1 over root 1 over root x. I have to simplify it a little bit. This is 1 over root 1 over root x. Yes? Which is 1 over x power a quarter. Fourth root, yeah. Right, so using a quotient rule in a quotient rule, the bottom. Yeah, but then it becomes like what I did at the beginning. So I want to keep it this way to show you could use the quotient rule. So it's the bottom squared. The bottom times the derivative of the top minus the top times derivative of the bottom. And what rule do I need for this derivative? Another quotient rule, which is the bottom squared, the bottom times the derivative of the top minus the top times the derivative of the bottom.
And do we need another?
Not here, okay.
Yeah, no, I can't think of any other way to do this. But the point is, all those three answers will simplify down to the same thing.
Yeah,
Of course.
It's the same question.
Same question, yeah.
If you only have
This rule makes this question be hard.
Oh,
Yeah.
Come on.
If you only have to use quotient rule, then
Yeah.
it should be easily found.
It is extremely rare that they ask you to simplify in the exam. In fact, 99% of the time they will actually say, do not simplify your answer. Yeah?
Yeah.
Yes, absolutely.
Question.
Right. What is next? Yeah.
Domain.
Good. Okay, well, it's whoever's question I hear first.
One.
What?
One set.
For which lesson? Domain?
Domain.
Okay, read it out to me.
No, each.
He got there before me,
No,
faster.
because-
What's the function? Okay, fine.
Me first?
Yeah.
Oh, okay. Negative 8 cos bracket 9x plus 2 cos bracket minus 6.
Like that.
Alexa?
Some respect, please. Right. What did I ask for?
Domain.
Domain.
Hey, I haven't done
Wait, did I ask for the domain? Well, that's easy. This is the domain. Yeah.
What are you doing?
He doesn't know, okay? Now, I think you had implicit next, wasn't it? Yeah, what? Yes? There's nothing else to say. You can leave it like this. No, both are fine. Yeah.
Okay, next. Okay, now.
Yeah.
Implicit
Yeah.
differentiation.
Yeah.
Number 11. Find the equation of the normal to the curve. C. X squared minus 2x plus y squared minus 2y minus 7 equals 0 and x equal to 1 and 0 less than y less than 5.
Okay, so here I want to find the normal. Remember, the normal is perpendicular to the tangent, and the tangent slope will be the derivative. So first I should find the derivative. Okay, so the derivative here will be 2x minus 2. Yep.
Plus 2y. 2y is x minus 2 y, yes. 0. The q equal 0.
Okay, what can I cancel? Cancel. I'll get dy dx equals x plus 1 over y minus 1.
Yeah.
Now,
Yeah.
Is it?
Minus x plus 1.
thank you, Monica.
Yeah?
Yeah.
Right.
You're right.
Now, here's the problem. I need to have x and y to calculate the slope. However, I have only x. So, how can I find the y? Yes, Sean?
Using that.
Put the x into the... No. Yeah.
Please use real words. Put an x
Put x
in
into x,
the equation. The equation. Right, so that's 1 minus 2 plus y squared minus 2y minus 7 equals 0. Yeah. Guys, please. This is your question. Listen.
Y squared minus 2y minus 8 equals 0.
So you get two answers for y,
Yeah.
Between
But
0
y is
and
between
5.
0
but y is between 0 and 5, so choose one of them. What are the two answers? 4 and 2. What? Yeah.
Y minus 4.
4 and minus
Y is 4, is
Y
it?
is 4 and minus. Yeah, no.
Yeah, y is 4. Yeah.
That's it.
So this will be, what did we say the x was? 1, wasn't it? Ah, we didn't even need to find the y.
What?
Because we said the x was 1.
Oh!
We didn't even need to find the y.
X minus x equal 1.
Yeah.
We have to. Y minus 1 can equal 0. Straight line.
True.
Yeah.
True.
But x minus x plus 1 equals 0.
What I did was minus 1 minus 5. It's the horizontal line.
Oh.
Is y minus 1 over
Ah, no. No, don't do that just yet. So guys, wait, we're not finished. We're not finished. So what we have is this situation. I'll draw the graph roughly. The graph might look something like this. And at the point, some shape like this, it doesn't matter. At the point 1, what was this?
Oh. Circle.
It kind of like a circle. At the point 1, 4, which is like here, it's the slope is it's horizontal because the slope is 0. Now I didn't ask you for the tangent. What did I ask you for? The normal. What's the equation of this line? The normal. Not true. Thank you. X equals 1 is the answer. That's the equation of a vertical line. We did this in week 1, semester 1. It was the last question on the lesson of equation of the line, which is the first lesson you did with me. So you're looking at lesson 1, week 1, question 9, part 2, I believe. Yep.
Wait!
Yeah.
I'm out of this time.
Okay then. Tough break, huh? Next, yeah, Monica, go ahead.
This is just a random question. It's not so random from England.
Inverse, yeah.
So there's this question about the 2 weeks,
Yeah,
and I had to find the time frame.
yeah.
And then I found them. Those are the weeks.
Yeah.
Like there were 3.85 and 6.16. And the answers we gave 4 and 6.
So my answer could be off a little bit.
Is it okay to round it like 3.85?
It's, yeah, I must have made a mistake, but as I was saying, Bruce asked me this last time as well. You actually have infinite number of domains.
Yeah.
So if you wanted to, you could actually round it up to the next whole number and just have the domain slightly smaller. In the exam, they were perfectly happy to leave it as a decimal.
Ask this question.
You asked something like it.
Oh, another question.
Yes.
Inverse number 1
Yeah, go on, what is it?
fx equals 3 cos 5x plus 3 pi.
3 pi.
Yeah, and then plus 3. Yeah.
What's the question? What is it meant to do with this?
You're supposed to find the domain.
Good. So here is a good question. Find the domain that will make this cost function be 1-to-1. Now, if you just had a good old-fashioned cos x by itself, this is just plain old cos x. What is the domain here that will be making it 1-to-1?
What is 1 to 1?
Minus 5. Oh, wow.
1 over 1.
That's 1 power.
This is the guy you're trusting your straightforward. I'm sure he's going to use that as an ironing board or something. You're going to come by to collect it, and he's going to be like, dude, I'm sorry, I need it for a few more minutes. I need to get my shirt ironed. No. No, have a look now, have a look. Think about this. It's not minus pi to pi, because this would fail the horizontal test.
Yeah. 0 to...
Minus pi to 0, or if I want to keep things in the positive, yeah, we could go from 0 to pi. This would guarantee it to be 1 to 1. Well, fine, but what about here? It's not quite as clear. But the idea was still the same. We require the angle to be between 0 and pi. It's just that in this example the angle is this.
Yeah.
Which we solved in semester 1. Oh, sorry, apologies. Plus 2 pi. I'm flip's sake. Minus 3 pi less than 5x less than minus 2 pi. I'm minusing 3 pi across. Yeah.
What is that? Where is that minus 2 pi come from?
Which minus 2 pi? This one? I minus 3 pi on everything.
Okay, Mr. Humphrey. That's it? How do I write that in here?
This is fine. In set notation it would be like this. Oh, I suppose these are closed. I can include them. There's nothing wrong with including them.
You can
Well, both answers are acceptable. They're both correct for the domain.
close.
Yeah. If I open this, I don't prevent it from being 1 to 1. I've just made the domain slightly smaller by not including the ends. No, it's just one of these answers. Okay, that was interesting. Next one, yeah? Do you have a question? No? Okay. What's the next one, KJ? Which lesson? K?
Yes, K.
Yeah, what is K?
Yeah, K.
Go on,
Okay.
read it to me.
Y equals x squared minus 4x minus 5 all over x squared minus 4x plus 3.
Plus,
3.
hi, and what do I want?
Yeah, what do you want?
Yeah. Excellent question. Great question. What?
Oh, but it is checking, is it invertible?
Is it invertible? Good. Is this invertible? What I'll do is I'll just change this to x minus 5, x plus 1, x minus 1, x minus 3. And this isn't quite y, it's probably f of x or something. Yeah, we'll say f of x now. Note, f5 equals f minus 1, which equals 0. Therefore, not 1 to 1. Therefore, not bijective. Therefore, no inverse.
Yes.
It's possible to have that kind of question about no inverse function and not by y is not.
Yep, I've seen that in the exam.
Oh.
You know, they might give you like a quadratic and say, explain why this has no inverse. This is perfectly acceptable way to explain it. Yeah.
Oh.
What is the name of cos inverse x squared plus x plus 1?
Okay, good. What is the domain of fx equals cos inverse
X squared plus x.
x squared plus x plus 1? Can I do this one? No, this is a good one. What's the domain here?
Anything?
No.
No.
No?
No. No.
No, cos inverse can be anything.
It cannot. Type in cos inverse 2.
Can be done too.
I feel like this has
Hang on.
happened before.
Let me just record the reaction here.
Error.
So you cannot cos inverse any old thing.
Isn't that wrong?
Yep.
0 to
No.
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 1, 2, 0.
Nearly.
Minus 1. Minus 1, 2.
1.
Correct. So you require that the angle, or sorry, not the angle, the value here is between -1 and 1. We did these problems in semester 1 algebra inequalities.
Why not bigger?
Remember how to solve this inequality?
Make it two equations.
That's right, make it 2 problems.
Yeah.
So you have this,
Yeah.
And-
Right.
this one.
Yeah.
Yeah?
Yeah.
So this is 0 bigger than x squared plus x plus 2.
Oh yeah.
Does this have roots? 2 and 1? No, this doesn't have nice roots. You have to use the minus b formula? Ugh. Minus b plus minus square root. B squared, that's 1. Oh, this has no roots. In fact, actually, hang on. Let me check something here.
Oh.
This is all real values of x. And here,
Zero minus 1.
and more or less, above or below.
Below.
So we need x to be real and x to be between -1 and 0. The only way x can be a real number and between -1 and 0 is if it's between -1 and 0.
Yes, it's required.
Yeah. So the domain is -1 to 0. Closed, actually. Yeah, sorry, these are all closed.
Teacher, what is that real number?
Because it's always over the zero.
Yeah.
But it has a minimum point.
So what? I need to find the value of x that
Where
makes
is
this
always
inequality true.
over
It is
the
true
zero.
regardless of the value of x.
Oh.
For what values of x is x squared plus 1 more than 0? For what values of x is x squared more than 0? When is x squared more than 0?
Because it's always more.
For all values of x. You know? It's the solution on the left is all real numbers satisfy the inequality. Every x will satisfy that. So it's really only the right that's interesting here.
Because it's cosine the x below your number, right?
Huh?
The question is cosine.
Yeah, then it's all real numbers, yeah.
Sure.
Yeah.
Why 1 to minus?
Good! Actually, Bruce or Sean. He's asking why -1 to 1?
I only know how to
Do the
align
cosine. Domain for cosine.
Oh, you're so close! You're so close! You said the wrong word. The range! The range!
range.
So, the reason is, here and here, if I have cost, the domain for cost is all real numbers. You can put anything in cost, but the only answers you get out from cost will be between -1 and 1. You know? You can't, if you do cost 100 degrees, cost 300 degrees, it's always going to give you a number between -1 and 1.
Okay.
So then, for the cos inverse graph, the domain of cos inverse is the range of costs.
Yeah.
Yeah? One sec, yeah? No? What's your question, Christy?
Today's one.
Yeah, what's the question? Read it out to me.
3.
Which lesson?
Today's left.
Oh, today's lesson. Okay, go on.
As y equal to -3 over 2 x -3 over 2x plus 3 minus 2.
Did you?
And what do I ask you to do?
A is 6.8.
A is 6 and 8?
Yeah.
Okay. So, this transformation, I'll just write it like this.
X.
Minus.
minus.
Oh, you have to do this.
6. Oh, 2. Actually.
2, yeah. -2.
Yes.
Alright, so first this becomes 6 minus 20, minus 12.
Ah.
Yeah.
Yes.
Oh yes.
Yes! And then
minus 12.
8 times -3 over 2.
Yeah.
Then why we have to times minus? Because it's just a reflection of the x-axis, so we just have to times 3 over 2.
Yeah, but then it's reflected, so then we have to times it by minus.
Oh, yeah. So we times everything and the result.
Okay, fine. If you're going to be like that, the minus, reflect.
Yeah.
Then,
Times
3 over 2.
Why you do this? Don't do this. Yeah?
Okay.
2 that.
Okay.
Now, reflect.
Reflect.
Yes.
Yeah, agree.
Okay, and then divide by 3 over 2, which is the same as multiplying by 2 over 3. Plus 2.
What?
Minus.
-2 means move to the right.
Oh.
So plus 2. And then here,
Minus down.
this is right, isn't it?
Yeah.
And then lastly, no, -14. -2, bring it down. Yeah.
Yeah, minus 14. But I mean, my question is,
No, the x is the one that's opposite, not the y.
the middle one.
-2 means move it to the right.
Yep.
The last
That means move it down.
Yep.
It does?
So it's that's why it's plus it's moved up.
Yeah.
Yeah. Do we have to do -3 over 2 x minus 2 because we cannot do like -3 over 2 is contrast by x days.
I don't know what are you asking me? What are you asking me? Really?
I mean the middle one.
Give me the question in one sentence.
Okay. And the original one, original equation.
That's already one sentence. Go on.
Okay, I already don't know. In the original equation,
Yeah, do you have to do this to this?
yeah, I mean,
I said earlier, I recommend that you do it, because if you do not, then you have a problem here. You have to think really hard about which you do first. Do you first translate, contract and reflect, or do you reflect, contract and translate?
No, you said it doesn't matter.
Not quite what I said. I said sometimes it doesn't matter. And the example I gave you is when you do something in the Y and then do something in the X.
Because when I do it like that, into like this.
Which did you do first? The 3/2 or the 3?
Reflex first.
Yeah, you see, I think this is the mistake. I have to double check it, but if you do not do this, I believe you actually have to run backwards through the inside because everything is reversed. So you would first translate, then contract, then reflect.
So I have to?
If you insist on keeping it this way, I believe you have to reverse the order from right to left. Now, I would love for you to do that and tell me if you get the same point at the end. Why don't you recalculate and see?
I think
Yeah.
I messed
Your card. It means you could have entered your PIN incorrectly 3 times in a row. Or there's a problem with their system.
Call them. I have done before.
Or the card's damaged, or their machine is damaged. For me, most of the time when this happens in a shop, it's because their machine is broken, and then when I go to another shop, it works.
As long as it is nobody next.
No.
No.
I should have money. 2 weeks ago.
Silver, next question.
That's the question.
Go for it.
Call them.
No. 4x squared plus 24 plus 5y squared
Plus what?
plus 5y squared.
Oh, 5y squared.
And
Implicit.
minus 10y
Yep.
plus 37 equals 0. And minus 4
Minus 4 comma,
2.
and I want the derivative.
Yeah.
Okay, let's look at this one, guys. I want the derivative at this point. So what's the derivative here? Firstly,
AX
yeah,
plus 25 plus
plus 24.
10y divided
Minus 10
equals 0. Equals 0.
So dy dx will equal minus 8x minus 24
over
10y minus 10. What is the x here? Minus 4. So that's 32 minus 24 over minus 10. Right? That's 6. Is that 18 over 10? 8 over 10.
Yes, your answer is wrong.
What did I ask you for? Did I ask you for dy dx? Is my answer like 1.2 or something?
Don't have difference.
Because did I ask you for dy dx? Or did I ask you for dx dy?
Yes, even if I...
Oh, okay.
It's a minor. You made a minor.
Did I?
Yeah, a negative, yeah.
More.
Which did I ask you for? dy dx or dx dy?
1.25.
Can you check? Is my answer wrong?
It's wrong.
Don't trust me. Really?
You said 4.
I said 4. Now, can you read the question to me? Make sure I didn't have any weird word in it. Does somebody have the question open, please?
No?
KJ? KJ?
Are you there?
Can you read the question to me?
No.
Okay, fine. Right, what's next then?
Bye.
See you tomorrow.
Fine, yep.
You have that.
We only have 3 hours left tomorrow.
Oh, we don't have VIP, right?
We don't have